All right, let's keep on keeping on here. We've got comparison tests. There are 2 comparison tests, and we're literally going to be doing that. You're going to be making a comparison. So here's our first one. It's theorem 10.14, which we all know is bogus, but I'll write it anyway. Comparison test. Now, I sometimes call this the direct comparison test. Your book just simply calls it comparison test. So we have 2, okay? So we've talked about, or I just said that we are going to have 2. It's going to be the direct comparison test, which is what I like to call it, or your book just calls it comparison test, and the limit comparison test, where we will obviously be using limits. So if I say direct comparison test, it's the same thing that we're looking at here. Okay, so we're going to let the series A sub k and the series B sub k be series with positive terms. Okay, with this criteria, now, if A sub k is less than or equal to B sub k, and the series B sub k converges, then the series A sub k also converges. I'm going to give it a little space because I'm going to write a little bit in between those. If B sub k is less than or equal to A sub k, and the series B sub k diverges, then the series of A sub k also diverges. Now, here's the deal. On this, whenever you're making these comparisons, so yes, I have these 2. A sub k is always what is given to you. So that's going to be the series that you are given in your problem. You are going to create the comparison of B sub k. You are going to create this comparison with the P series in mind. All right? So A sub k is what's going to be given to you automatically. Then you are going to create this B sub k comparison series here with, both of them have positive terms, of course, but with the P series in mind is what you're going to happen. If the created here is bigger, so you create, the one you created is bigger and that converges, then the original also converges. All right? If the created is smaller and diverges, then the original also diverges. So what you need to realize, if the bigger one converges, so does the original. If the smaller created diverges, then so does the original. All right. If this does not happen, then this test is not valid and you have to do a different test. So if you do this work and you end up with, I get this big one, but the big one diverges, then this is not a valid test, right? It has to converge in order for the created one being bigger to work. Do you see what's going on there? So again, I would highly recommend, just like we have, make your flashcards, right? Make your something where you're laying out all these different tests so you can keep them squared away. Now, I will tell you at the end of, 10.7, that's our last one out of this. I am going to give you a chart that kind of lays this all out. If you wanted to look already, I'm just looking in the book right now to see what page it's on. If you have a book, it's on page 701. That's every single test that we go through, that's a chart of how to determine convergence for every single test we go through. Now, we haven't gone through all of our tests yet, so I'm not going to pull that chart out. Once we finish going through all the different kinds of tests and all the different criteria and you practice that, then we'll have that sum up chart. All right, so just heads up, that's coming. All right, so back to the direct comparison test. So that's the deal. If the created is bigger, converges. If the created is smaller, diverges. So let's do it right now. Here is example 1. Let's go black on it. I'm going to keep this up here so that you can see what it is. Example 1A. I have this series. K is going from 1 to infinity of k cubed over 2k to the 4th minus 1. Now, this is obviously a sub k because a sub k is the original of what you have. Now, I want to create something that deals with the P series, and it is, it deals with the P series, and it takes the lead behavior is kind of what I want to say. So if I'm looking at this problem, I'm seeing, okay, I've got this rational expression. So that's a tip off. We're going to use comparison. If you've got a polynomial in the numerator and denominator, that's a good tip off for comparison test. So here I have k cubed over 2k to the 4th. So my b sub k is going to be k cubed over 2k to the 4th. All right, which if I simplify this rational expression, I end up with 1 over 2k. Now, what do you know about 1 over 2k? If I were to think about this in terms of the P series, so if I have my series here of 1 over 2k, what do you know about that? Yes, it's harmonic because it's k to the 1st power, right? That 2, nobody cares about that 2. Bring that thing in front if you want. So bring this 1/2 in front. That's just a constant. Nobody cares about the constant, right? The kicker here is that I have this 1 over k. And then we know that this is harmonic, so that this diverges, right? Okay, so we now have to make a comparison when I'm looking at this. So I have k cubed over 2k to the 4th minus 1. And I have 1 over 2. Nope, I'm not writing it like that. I think it's easier to make this comparison. K cubed over 2k to the 4th. My question is, are we going to have a greater than or equal symbol or like that? Which symbol is it that we're going to use? That's what I don't know. All right, I should have scooted that down, but whatever. We are looking at the simplified version to determine P series, but I think it's easier to look at this. If your numerators are the same, then nobody cares about them. They're the same, so you're good. 2k to the 4th and 2k to the 4th minus 1. What happens with those denominators? For instance, if I have something like 1/3 and 1/2, which one's bigger? 1/2, right? If I have a smaller denominator, that means I have a bigger fraction. Of these two, 2k to the 4th and 2k to the 4th minus 1, which one is the smaller denominator? Because I'm subtracting 1, right? So because I'm subtracting 1, I know the one on the right is going to be my smaller denominator, telling me that my symbol goes like this. So now b sub k is smaller. My comparison here is smaller. And I know that my comparison diverges. So if my comparison is smaller and it diverges, what do you know about my original? It also diverges. Therefore, the series k goes from 1 to infinity of k cubed over 2k to the 4th minus 1 diverges by comparison test. So when you do the comparison test, you're looking for the p-series, but you also have to know something about fractions here, right? You have to be able to compare these two fractions in order to determine which one's bigger, which one's smaller, and how any of that kind of stuff works. All right? Okay. Now here, let's do this one. Not on this page. And work at this one a little bit. Example 1b. So this one doesn't necessarily look exactly like a polynomial over a polynomial, which is okay. Natural log of k over k cubed. You can still use a comparison test on this because you're literally comparing something. The kicker here is, what am I comparing so that I can make a p-series out of this? Natural log to. So I'm going to give you a hint. If I have this graph, here is the graph of the natural log of k. Or we'll use x here in this instance because we're on an xy coordinate. What if I have this line? What is that line? That's my identity, right? If that's y equals x, then you can make this comparison. So you can set this up as your a sub k is equal to the natural log of k over k cubed. Your b sub k is equal to k over k cubed. Do you see that? So if I want to make this comparison, in this instance, my denominators are the same. The question is, which one's bigger? Looking at this graph, is natural log bigger or is y equals x bigger? Y equals x, right? And x, k, whatever, that's just the input. The input is the input value there, right? So if I have this, if my comparison is bigger and I simplify this to 1 over k squared, p is equal to 2, which is greater than 1. So then I know that this is going to converge by the p-series. Therefore, if my big one converges, what do you know about the original? It also converges. Do you see what happened there? So the big deal when it comes to this direct comparison test is you are literally directly comparing these two scenarios, my original series and my created series with lead behavior. Your goal with this is to come up with something that goes with the p-series. So typically you have a polynomial over a polynomial, and a lot of times you'll just have a monomial down here or 2 terms maximum, like we had in this other one, right? Just these 2 little terms. Just a small, tiny little polynomial rational expression, right? Polynomial in the numerator and denominator. So something nice and easy to work with. That's our goal, and that's what we're looking for here.